So how would we do this?
That's a good question. Like, I mean, something, but that's, I think, more guessing. Like, it's like that if we invest half of our capital or something like this, or a certain percentage, let's say, and then we either win or we lose, and then we take like a fraction of that percentage that we won or we lost and put it in again, kind of to, but not really sure how to get there.
Let me show you. So we've got positive and negative numbers, right? And so we want basically every time we win or we lose a fraction. Yeah. So what we can do is we just define a fraction f, and then we multiply with our winnings. So if we win, say 2% or 10% or whatever, so it's like 0.1 times plus 1 or 0.1 times minus 1. Yeah. Now, what we want to do is we want to reinvest our winnings, right? So we want to put the money back in. So what do we need to use if we reinvest our winnings? What sort of, if we, do you remember when we don't reinvest, we deal it with percentages in a certain way, and if we reinvest, we deal with it a different way. Remember this is really important. When we not reinvest, we use a cumulative sum, but when we reinvest, we use a cumulative product. So in this case, we don't really need to use a cumulative product. We could just use a product. But when we use a product and we multiply small numbers, percentages, we actually need to add a 1, right? Because if we don't do that, it will just go straight to 0. So let's just do this. So when we do this, all right, we've got our plus 1s and minus 1s, okay? So what we then want to do is we want to multiply this with our fraction. Yeah. So let's just say f. What percentage should we start with? F equals, what do you reckon?
10?
10. Okay, so it's 0.1, right? 10%. So we do this times f. And then we put a bracket around this, and we have to add a 1 to that, right? And so see this? So it's like 1.1, 1.1, and then 0.9. So 10% up. And then what we can do is we can go something like our result is now the cumulative product of this. And I just want to reduce the numbers a little bit just for the plotting. So we run this, and then we can do something like plt.plot r. And you can see it basically just does some stuff and then goes to 0, right? So it's like, oh, not great. Let's maybe run 10,000. Maybe we are a bit more lucky with that. Well, look at this. It just goes to 0 and then stays. So that's not a good guess. What do you reckon, more or less?
You mean for the random numbers or for the percentage?
For the fraction. Shall we just go and find out? Let's think about this first. So if you put 100% of all your capital in each coin toss, say your $1,000, and then let's say you win, you double, you win, you double, you win, you double. After, say, 100 coin tosses, the probability is pretty high that within those you have one loss and you lose everything, right? So if you put all your money into it, then you almost guaranteed to lose at some point. Yeah? Or you're pretty much guaranteed to lose, because the chance of not losing is just so small. It's 50% of in the first coin toss, 0.2%, 0.25, and the next one 0.125, and it just goes down really fast. So the probability of not losing is just really, really small. Okay. And so after 100,000, it's like nothing. Okay. So now if you if you put a tiny amount of your $1,000, and say you have $1,000 and you put in 1 cent every time, it basically means, you win, you lose, you win, you lose. But then you might double your 1 cent to 2 cents, right? But then it goes down. And what that means is it will take a phenomenally long time, because your expectancy of your 50% is almost 50-50, meaning your capital hardly grows. You still have more or less $1,000, but then you end up maybe with $1,000.10 or something after 100,000 coin tosses, right? Because you just put in such a small amount. So that's not really a great strategy either, because it doesn't really help.